This video is going to talk about logs in an introduction. Logs are exponents and they are a number. If you can keep that in mind, that'll make logs go a little bit better. Now when you see log that looks like this here, it's read log base b of x. So the base is going to be some little subscript number down here. And then you're going to have this x, which is actually called an argument. So y equal log base b means that y, over here on this other side, remember logs and are exponents, so y is the exponent on b, the base, that will give you this x. So we want to simplify these logs, and remember it translates to find the exponent on the base that makes the statement true. So if I have log base 2 of 8, I'm really saying 2 to the what is going to be equal to 8. And we all know that, hopefully, or you could always calculate it yourself, 2 times 2 times 2 is 8. So 2 to the third. Log base 2 of 8 is equal to 3. That's the exponent on 2. So again, over here, log base 3 of 81, it's what exponent on 3 will give me 81? And if you don't know, you could always use your calculator. You come in here and say, okay, well, 3 caret x. Sometimes they give you a really big number that you just don't know what happened to what it is. Then we can go look at our table, and let's look at some smaller numbers here. Now if we look at our table, and we're looking for 81 in this y column, and it looks like it's 4. Right here is 4. So we would say that log base 3 of 81 is 4. Notice, I found that log by actually thinking about the exponential. Let's look at this one. 5, log base 5 of 625. So again, not 6, 5 to the something is going to be 625. Well, I know that 5 to the third is 125. So I would guess that 5 to the fourth is going to be 625. And I could always take 125 times 5. This would be the long way to go, but carry the 2. There's 10 plus 2 makes 12. 5 plus 1 more makes 6. So sure enough, or 5 to the 4 is 625. Lots of ways you can figure these out. Sometimes you just know them. Sometimes you could use your calculator. Sometimes you could use what you know to help you get to the next part. 4 squared is 16. And if that's 4 squared. Doing it the long way again. If I multiply that by 4, I'm pretty sure that's going to be 64 because 6 times 4 is 24. Carry the 2. 4 plus 2 more would be 64. So I had 2 factors, I got 1 more. So 4 to the third must be 64. You can also express these like by converting it. Log base b of x is equal to b to the y equal x. I always say it's like hopping across the pond. You take the base, because we know exponentials start with bases. You hop across the pond to get the exponent. Remember, that's the exponent over here. And then you hop across the equal sign to get to the other side. So you start with your base, we hopped across to find our exponent, and then we hop back across to get to what it's equal to. So 2, hop across the pond, gives us 2 to the 7th, and that's going to be equal to this x. 2 to the 7th, we could just go right to our calculator with that, and just go back to our home screen. 2 caret 7, that's something we can compute. And 2 to the 7th is equal to 128. So x must be 128. Now this is our answer right here. But the true statement would be log base 2 of 128 would be equal to 7. Right, convert this one. We start with our base, that's x. Hop across the pond to get the 2. And then that's equal to hopping back across the pond, equal to 36. Variable now is our base, and we can take the square root of both sides. So the square root of x squared is going to be x, and the square root of 36 is going to be 6. Now, some of you might be saying, isn't that supposed to be plus or minus 6? Well, remember about bases. The base has to be greater than 0. And so we can only accept the x equals 6. Let's try again. Start with your base, hop across the pond, negative 4 is equal to hopping back across the pond, the x. So 5 to the negative 4 is 1 over 5 to the 4th. And I think earlier we found out that 5 to the 4th was 625. So using that fact now, we have 1 over 625 would be equal to x. And that is a perfectly fine answer. X raised to the third is equal to the 8. If you can just keep reminding yourselves that the other side of the equal sign is the exponent, then this conversion can be a little bit easier. Or maybe hopping across a pond helps, I don't know. Again, my base now is my variable, so I can take the cube root of both sides. This gives me x on this side, and the cube root of 8 is 2. Or if you needed the calculator, you would say, go to math, cube root is 4 of 8 is equal to 2. We can also calculate some logs if they are common logs. That's base 10. That's what our number system is based on. We got our ones, our tens, our hundreds, our thousands. We're on base 10. And so that's why we call it the common log, because that's our number system. So we have a log key because we use it so often. And then base E is 2.718, blah, 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 blah. It's a natural number. It's called the natural log, and it's ln. That's not an I. It's an L. And in Latin, this would be logarithmic naturalis or something like that. So that's why it's ln. The L comes first, in case you care. And so we can just calculate these right from our calculator. Log 60. Notice there's no subscript down here because we know it's base 10. So just log in our calculator and then 60, and log 60 approximately 1.78. And then we can do the same thing with the ln. Now the ln is below the log key, and it's ln 3.5, and we get 1.25 approximately. So now we know how to figure out logs. If they're logs or natural logs, we can go to our calculator. If they're equations, then we can convert them into an exponential and go from there. Or if they're just asking us to evaluate a log, we just have to think, what is the exponent on our base? That'll give us this number, which again is called the argument.